Hi, everyone. So this is chapter 6 for adult development. This is all about attention and memory. So I am going to post another video for you here that goes through this modal model or the 3-box model of memory in greater detail. I will also post for you a video that details the badly working memory model as well. Okay, so I will post both of those things for you that go into these in greater detail, but this should be review from intro psychology. So hopefully you remember we take in information using our 5 senses. That's sensory memory. It's held here for a very, very brief time. If we decide it's important, we pass it on to short-term memory, which working memory is a component of short-term memory. And this includes the information that we are actively using at this particular point in time. Remember, as we talked about in class, that this is limited in terms of its capacity, in terms of its storage capacity. And then if we decide that information is important enough, we pass it on to the final stop, long-term memory. So long-term memory, remember, contains all kinds of stuff. So our memories for personal events, our memories for things that we know in terms of general facts and information, things that we know how to do. Long-term memory is infinite in its storage, okay? So, and then we have to be able to, of course, get that information out of long-term memory when we need it. So we refer to that as retrieval, right? Being able to access it when we need it. And remember that for us to form a memory to begin with, we have to do what we call encode, right? Or encode that information. So that's what you see here, this encoding process. And encoding is basically just making sense of something, assigning it some kind of meaning so that we can store it, right? And so that we can access it when we need it. All right, so information processing then, this is essentially what we're talking about here when we are referring to how do people remember information? How do they make sense of it? And that's really what information processing is all about. And when we're looking at some of the age-related changes here, we do definitely see that the speed of processing, so how quickly older adults can make sense of new information, that this slows down over time. And that makes sense if you think back to what we talked about with intelligence and how that fluid intelligence does change over time. Well, that's really connected to processing speed. But it also is very strongly connected to what adults are actually asked to do. So when we look at specific kinds of tasks, we might find that some kind of task that I do all the time. So for example, driving a car, that might see fewer age-related declines compared to maybe being asked to do something that is brand new. All right, so when we look at these information processing attention resources here, we're talking specifically then about how much of my attention, so remember, attention is a finite resource, meaning I only have so much of it. So how much of my attention can be devoted to a particular situation? And so again, we do see age-related declines here. And 2 of the possible reasons that we see those age-related declines are connected to, first, what we'll call inhibitory loss. So inhibitory loss essentially means that older adults have more trouble filtering out or not focusing on information that is irrelevant. So they have a more difficult time with this compared to younger adults. So older adults have more trouble kind of blocking out the noise, right? Or the stuff that I don't need to focus on to be able to remember something or to be able to learn something. Older adults, though, can, of course, learn specific strategies here to try to filter out irrelevant information. So, for example, if I'm talking to someone on the phone and that person is telling me I need to remember maybe a phone number to call or the location of an office that I need to go visit, I might filter out irrelevant information. So maybe visual information would be irrelevant at that point because I'm listening. So maybe I close my eyes as I'm imagining where I'm going to go, right? Or I close my eyes as I'm listening to the person telling me what are the next steps that I need to follow. So close my eyes when I'm listening to something to filter out the irrelevant visual information. We also, though, see that one other reason for these age-related changes are changes in attention. So things to note here. So older adults are, generally speaking, they're not worse than younger adults at being able to divide their attention between two competing tasks, but they are slower than younger adults are. So in general, older adults are just as able to multitask compared to younger adults, but they typically perform each task slower compared to younger adults. So that seems to be the age-related change here. So for older adults, then let's say that they're trying to remember something and they're walking at the same time. So we've got two different tasks going on, memory and walking. So for an older adult who maybe walking is slightly more difficult than it is for a younger adult, they may prioritize walking and balance, because that's the more important piece right here, right now, over remembering something, which perhaps is not quite as important at this particular point in time. All right, so let's talk then about processing and attention. So we've got two different types of processing here, and we'll talk then about the age-related changes that we see. So one type of processing is what we call automatic processing. So this is kind of that unconscious automatic process where it's something that I've done over and over and over again. And so I'm very familiar with it. I know how to do this. I could do it in my sleep. So with automatic processing, we don't typically see the age-related changes. So automatic processing, think about something like driving a car, right? Where you do this all the time, brushing your teeth, right? You do this all the time. You know how to do this. You could do it without thinking. It's so routine. You don't really have to devote a lot of attention resources to it, right? Or a lot of effort. So in those kinds of tasks, we don't typically see age-related declines. But on the other side, with what we call effortful processing, so effortful, that already tells us that this requires effort, right? This requires some degree of work on your part, where you are deliberately either trying to learn something new, you're consciously trying to remember something, consciously trying to teach yourself some kind of new skill, new task, or commit information to memory. We do see that there are age-related differences here. So younger adults are faster at this. It takes less effort, less cognitive effort for them to be able to learn some kind of new task. For older adults, it takes longer and requires kind of more deliberate attention for them to be able to learn something new. So this becomes more taxing then on memory and also on attention resources for older adults when trying to learn something new that does require that degree of effortful processing. All right, so memory processes then. We're going to talk here about working memory. So remember, working memory is part of short-term memory, which is that middle box in that 3-box model. So working memory, when we're using our working memory, we are typically rehearsing information. So think, if I ask you to remember a list of words, oftentimes what you do is you repeat the words over and over and over again in your mind, right? You'll repeat those. That's rehearsal, right? So you're using that information, you're practicing it, you are rehearsing that kind of over and over and over again. We do see that there are some declines in age with working memory capacity. So remember, working memory is limited to begin with. We talked about Miller's magic number 7. So that's 7 plus or minus 2 pieces of unique information. That's our general working memory capacity. But with age, we do see a reduction in that storage capacity. So older adults have a more difficult time kind of storing multiple pieces of information in that working memory. They also see declines in how much attention they can allocate to more than one task at a time. Okay, so that multitasking, remember, it becomes slower, requires more conscious effort on the part of the person. And we also see that working memory becomes slower at processing incoming information. So working memory does decline working memory does decline with age. However, the declines are not universal. So meaning that for certain individuals, we will see differences, individual differences in how working memory changes with age. So we do tend to see that for spatial memories, the declines are typically greater, right? So greater for spatial memories. So remember, spatial memory is memory for space, right? Yeah, so memory for where things are located, memory for certain routes, right? Or like how to get from point A to point B, over verbal working memory. So typically older adults will retain that command over language, right? So no real issues with that, but we do see a decline in that spatial memory. And we also tend to see that adults will experience more difficulty in the evening compared to in the morning with working memory. So if you have heard of what's called sundowning with Alzheimer's disease, this basically means that symptoms get worse as the day goes on. And we do see that also with working memory. And then also, of course, on tasks that are more complex compared to more simple or straightforward tasks. So we see bigger declines there. All right, so this is our model of long-term memory. So again, I will post a video that goes into this a little bit more, but we'll focus on some of these changes in long-term memory types. So some of the differences that we see then in terms of long-term memory changes. So semantic memory is basically knowing that, or knowing factual information. This does not really seem to be overly affected by age. So that's a good thing. So remember, we talked about that crystallized intelligence staying consistent, that actually increases as we age. Semantic memory is a form of crystallized intelligence. It's knowing general facts, general figures, general information. 2 + 2 = 4. The earth is round, right? All of those are semantic types of memory. We do, though, see that there are some differences in what we call episodic memory. So episodic memory, this is memory that is connected to specific events or specific points in time. Older adults are generally worse than younger adults on tests of episodic recall. So this would be trying to recall when a specific event happened. So if I tell you, tell me when John F. Kennedy was assassinated, what year was that? That might be a difficult thing for older adults to recall compared to younger adults. But we do see that there's less difference on recognition tasks. So recognition would be like a test of multiple choice, where the answer is there, I just have to pick it out, compared to recall, where the answer is not there and I have to kind of find it in my memory. So essay exams are good examples of types of recall tests. Autobiographical memory, though, is more resistant to the declines in memory that we see. With autobiographical memory, we're talking about memories that are specific to your life experience. So we do see less decline compared to just general episodic memory, so memory for a specific event or a point in time. We do also, though, see that there are some differences in terms of retrieval. So with retrieval, older adults, generally speaking, use fewer retrieval strategies. So remember, retrieval is being able to get to the information when I want to access it, when I want to remember it. Older adults use fewer of those specific strategies to get to the information. So a retrieval strategy might be something like trying to remember what was happening around when I formed that particular memory, using the context, right, or using my emotional state as a retrieval cue. And older adults, generally speaking, use fewer of these retrieval strategies compared to younger adults. I will also post for you an example of a video where people have exceptional both encoding strategies, so how did they make sense of the information, and then retrieval strategies, how did they actually get to that information when they need it. All right, so for prospective memory, this is a type of memory that you may not have encountered before. With prospective memory, prospective meaning something that is future oriented. So prospective memory is remembering to do some kind of planned action in the future. So I'm remembering to do something maybe after a certain period of time. So for example, after 15 minutes, I have to call someone back. That would be prospective memory. Or it might be, that I have a dentist appointment 3 weeks from now. Those would both be examples of prospective memory. So the idea here is that for older adults, that they need to be able to remember things that are in the future here, and that there are certain things that can help with that. And that's basically what you see in this model, this image over here. So for prospective memory, then, we need to monitor this in terms of what we'll call the event cue. So event-based, remembering that I have a dentist appointment 3 weeks from now, or monitoring for the time cue, which is the time-based prospective event. So I need to call someone back 15 minutes from now. And so to be able to do this effectively, I might then need to provide myself with some kind of retrieval context to make this happen. So if I have to remember to call someone 15 minutes from now, I might do a timer on my phone, right? Or, maybe on the microwave or something like that. If I have a dentist appointment 3 weeks from now, well, then I could write it down. And both of those would be retrieval cues for me to be able to get to that information so that I can remember it, so recall it, okay? And then actually be able to do it, which is the execution piece. Older adults, generally speaking, benefit from prioritizing particular tasks. So making a list of things that are maybe the most important right here, right now. So what do I need to get done today versus what do I need to get done several weeks from now? All right, so this is memory in context. So this is essentially showing you older adults versus younger adults. Okay, so the younger adults we see here in the orange line, older adults here in the pinkish line, and looking at the proportion of memories that are recalled between a particular point in the lifespan. So as you can see here, for older adults and for younger adults, events that occurred in our lives between ages 10 and 30, these are reported more often compared to events that occurred in middle adulthood. And you can see that here with the shape of the curve here, right? That the 20 year span, right? That seems to be where we're recalling the most memories, and then we do see a decline, right, or a drop off as we move into older age. And so this is essentially looking at that autobiographical piece of memory. So memories for specific things that happened in your life. That's a form of episodic memory. And we do also see that we're likely to remember very emotionally significant kinds of events. So things maybe that had very great personal meaning for you. So think maybe graduating from high school, your prom, right, in high school. Graduating from college. So those kinds of things are things that we are very, very likely to remember. And so keep in mind also that there are a lot of significant life events that are happening between ages 10 and 30, right? So big markers during that particular point in time. And so that makes sense then that we would then remember those events even well into old age. All right, so when we talk about factors that preserve our memory, so this is things that are connected to our cognitive capacity over the course of the lifespan. Look what's back, big surprise here, not really, exercise, right? So exercise, of course, gets oxygen to the brain. It increases that neural plasticity. So plasticity meaning the ability for neurons to change, right, to form new connections. So if they're plastic, they're flexible, right, they grow. It also, exercise prevents that age-related decline that are connected to memory. So things like reduction in brain volume, exercise can actually prevent that from happening. So more reasons, right, to help you get into exercising. Multilingualism. All right, so this is a big one. So people who speak 4 or more languages languages, that this actually strengthens those PFIT connections. So remember the parietal, right, and the frontal lobes. So remember that PFIT theory essentially states that people who are more intelligent have more connections between the parietal and the frontal lobes. And so multilingualism, knowing multiple languages, actually strengthens those connections and helps prevent memory decline over time. Another one here, using semantic memory in service of episodic memory. Okay, so we did say that semantic memory is one of the forms of memory that is likely to be shielded from those age-related declines. And so we might then use semantic memory, memory for meaning, memory for general information to support my episodic declines, right? So episodic memory for specific events, for specific context related information. So for older adults, then we might use that semantic memory to help support that episodic memory. And then also, as we talked about in chapter 8, there are many negative stereotypes about aging and memory decline. And we do find that when older adults buy into those stereotypes, that for example, everyone who's old can't remember, right? Or every older person has a terrible memory. When we believe those kinds of stereotypes, well, guess what? It actually affects our ability to remember things. So when we buy into those negative stereotypes, we're less likely then to be able to remember things well. And so we need to combat those stereotypes as much as possible. All right, when we talk about memory training, then we've got some specific ways that we might actually train our memories to work better. So you see modeled here what's called the EIEIO model, which is also presented in your book, but it's basically looking at the E stands for explicit, the I stands for implicit. So explicit, things that are out there, things that are in your face to help us remember things. And the I, implicit, stands for things that are perhaps internal, things that are implied. The second E also stands for external, right? So things that are outside of the individual person, and the I, internal, things that you're doing in your mind, right? So cognitive kinds of things. So when we look at an explicit memory aid, that could be seen as something that is external, writing something down in an appointment book, writing down a list of groceries. External, implicit kinds of aids. So having color-coded maps. So instead of maybe pointing or like writing down directions for a person, having some kind of map where a certain color means there's a certain resource that's here that's available for you. Sandpaper letters. So these are letters that are made of sandpaper and they have a feel to them. And that feel, kind of creating that additional tactile sensation, sensory memory, then that then enables us to be able to form one additional connection to be able to get to that information when we need it. Mental imagery, so imagining something, right, kind of forming a picture in your mind, or rote rehearsal. So rehearsal is the repetition. I'm trying to remember a list and I repeat that list over and over and over again. Spaced retrieval as another example of a memory aid. So you might, hopefully you use this when you're studying, but basically the idea is that if we kind of chunk information, right, or block it into maybe 30-minute blocks over several days, and we keep coming back to that information over and over and over again, then we are more likely to be able to remember that information and retain that information. So spacing out the time in between when we access it. And then of course, conditioning. So forming some kind of association. So for example, if I need to remember to take my medications, well, maybe I always take my medications when I have my cup of coffee in the morning. And so I start to associate, I have my coffee, I take my medications, coffee, medication, coffee, medication. So putting those two things together in time essentially then serves as a memory aid and helps me to be able to remember when I have my coffee, I always take my medications. So there are lots and lots of ways to enhance our memory. All right, and when we talk about memory testing then and some of the clinical issues that come up here, this is a challenge, right? If we want to try to distinguish between typical normal age-related changes in forgetting versus some kind of clinical issue, so dementia, for example, as a clinical issue. And so what we want to do here to try to distinguish between what's the normal expectation and what perhaps is cause for concern, we might want to look first at how do the changes in memory connect to this person's ability to function in everyday life. So there's a big difference between, let's say, maybe forgetting where I put my keys, but then I eventually find them, compared to I forget to turn the stove off, and that's obviously seriously jeopardizing my health. Or I drove to the grocery store and now I can't remember how to find my way home. So those are probably more serious issues. However, this is a challenge, right? It's difficult. It's oftentimes very, very difficult to tell the difference between what is normal age-related forgetting and what is not normal age-related forgetting. And so one thing to note here that I'll just reiterate is that changes related to dementia, remember that that involves structural changes in the brain. So those plaques and tangles, right, where those axons get tangled up, those are not normal age-related changes in memory, right? Dementia is not a normal part of the aging process, but oftentimes it's very difficult for us to tell the difference between normal age-related forgetting and things like dementia, right, which are not normal age-related forgetting. We also see that issues connected to mental health and physical health, where damage to the brain could potentially be involved here, that those particular issues can also present as memory loss issues as well. So this is a very complicated kind of issue. There's a lot of testing that might be done to distinguish between memory issues. And when we talked about the Wechsler Adult Intelligence Scales, right, or the WAIS, some of those working memory tasks like the digit span, the letter number sequencing, some of those could potentially be used as tests of working memory to determine what's going on in terms of the person's memory issue. But again, telling the difference is often quite challenging. All right, so that's all we have here for chapter 6. I will post those additional videos for you. I hope that you enjoy your time off today. See you later.